These armored cavalry soldiers are mounting up for training maneuvers, not a war, confident that if it were for real, they would be serving in the best armored, most deadly battle tank in the world, the M1A2 Abrams.
Fire!
It's called the Queen of Battle because if you're an armored person who grew up in the armored branch, you perceive it to be the thing that wins wars.
In addition to being almost impervious to attack, these high-tech fighting machines can maneuver easily around almost any kind of obstacle.
It provides tremendous protection to the soldier, has great lethality. It strikes fear in the heart of the enemy.
Before the Abrams became operational in the 1980s, it faced a whole series of technical and political hurdles. Its successful deployment was due, in part, to lessons learned over almost a century of armored battles. The first tanks used in modern war were fielded by the British and French to break the stalemate of trench warfare in World War I.
If you go back to World War I, where they were bogged down in the trenches, it was finally the invention of the tank and the introduction there that permitted them to break through and open up the battlefield.
The early tanks, developed by the British and the French, were an attempt to move across terrain that had been churned up by artillery fire. They had caterpillar tracks, and that enabled them to cross terrain that was too difficult for vehicles using rubber tires.
However, these early tanks were easy targets for concentrated enemy fire and often broke down because of mechanical difficulties.
And so there were only limited successes on the part of the Allied tank attacks, although there was enough to encourage the United States to develop its own tank forces.
The U.S. did begin to train soldiers for tank warfare after World War I, but the Army didn't want to spend much money on armor. The cavalry was mounted on horses, not tanks.
And they were not interested in these big, clanking, smelly things that the armor people wanted to push on them. People like Eisenhower and Patton got out of armor into other parts of the Army because there was no chance for advancement and it was underfunded.
In the 1930s, the Germans, led by General Erwin Rommel, built an intimidating force of powerful heavy tanks. His panzer divisions nearly obliterated the Allies in the early years of World War II.
Rommel was a key proponent of the German concepts for the Blitzkrieg, the lightning war. His concept of lightning-fast attacks followed up rapidly with follow-on forces. In World War II, enabled them during the spring offensive in May and June 1940 to overwhelm both the British and the French forces that were arrayed against them.
Under this vast roof, dozens of tanks are going together at one time, rolling from stage to stage.
When America entered the war in 1941, auto factories in the Midwest were quickly converted to supply the Army with its first tanks, called the Sherman. The Shermans were smaller and lighter, with less armor protection than the German tanks. Their size and design made them easy prey for the bigger German tanks' armor-piercing shells.
The Sherman turned out to be a fairly vulnerable tank. One of the reasons was that it used gasoline as its fuel, and if the tank was hit, the gasoline would burn. Soldiers on both sides started calling the Sherman the Ronson, a name for the Ronson cigarette lighter.
As a result, General Dwight D. Eisenhower, the Allied commander, demanded a tank with more protection.
General Marshall, who was the chief of staff of the Army, essentially told General Eisenhower, look, even if I wanted to give you more protection, I couldn't move the tanks from Detroit to the seaports because they couldn't get through the tunnels, or they couldn't get on the ships. They had to be moved by railroad, and they couldn't get through the railroad tunnels if they were any bigger.
Nonetheless, the American armor forces in Europe, especially under General George C. Patton, an expert tank tactician, were able to overcome those difficulties. Using the Sherman's superior speed, the Americans were able to outflank the German tanks, attacking them on their less well-protected sides and backs. They also had the advantage of numbers. 50,000 Sherman tanks were produced by war's end.
One of the tactics they used in World War II, when the Americans were up against a superior German tank, they would simply surround it and outnumber it. We might lose a few, but then eventually we would win that engagement.
The Soviet Union also developed a huge tank force, which eventually swept through the German forces on the Eastern Front. By the end of the war, the Allies credited their large, flexible armored forces as a key to victory in Europe. The U.S. came away with a host of valuable lessons in armored tactics.
And by the end of World War II, the concept of combined arms, mechanized operations, and the tank, working in close concert with tactical air support, had been firmly set in U.S. military doctrine.
Nevertheless, when the war ended, the U.S. tank program suffered. The onset of the Cold War with the Soviet Union altered priorities. Much of the military budget was funneled into missiles, bombers, and nuclear submarines, not tanks.
So there was a long period after the war when the Army struggled along with what really, compared to what they might face on the battlefield, was an inferior tank. They took the basic Sherman tank from World War II and adapted it and adapted it and adapted it, but never really built a new tank.
The adaptations of the Sherman culminated in the M60 tank. Nevertheless, Pentagon strategists feared that the Soviets' huge, sophisticated tank force would overpower the U.S. and its NATO allies if a ground war ever broke out in Europe.
In the Cold War, our greatest concern was of a massive conventional attack by the Warsaw Pact against Western Europe. And as the Soviet Union upgraded its own tanks, we wanted to be in a position to have a superior weapon.
But certainly vis-a-vis the Soviet tanks, the M60 was no great shakes.
So in 1963, Secretary of Defense Robert McNamara decided that the U.S. should join forces with the Germans to build a superior battle tank for all of NATO.
I was delighted with the results. An agreement to enter into joint research and development projects, the first of which will be the development of a new main battle tank to be jointly financed by our two countries.
It was called the Main Battle Tank 70 for the year it would be deployed. However, the program soon ran into difficulties.
As the program matured, more and more the differences in national priorities entered into the picture.
It started to come apart on all sorts of different ways. For example, the United States used inches, the Germans used the metric system, so they finally decided that the parts that the Germans made would be metric, the parts that the Americans made would be in inches, and then a great compromise where they came together, they would be metric. The Germans won that round.
Emergency medevac, ASAP.
Even as the two nations struggled over the design of the new tank, America went to war again, not on the plains of Europe, but in the jungles, rice paddies, and highlands of Vietnam. The terrain hampered the tank's effectiveness.
I commanded a cavalry troop, armored cavalry troop, and in that troop I had 9 M48A3 tanks. They could go just about any place, drive through the jungle, knock the trees down. It slowed you down, of course, but we could go just about any place. Once in a while we would get stuck in rice paddies or mud holes. There were some times during the year in the monsoon that you had to be careful what you did.
General William Westmoreland, commander of the American forces, was not convinced armor had a significant role to play in an unconventional guerrilla war like Vietnam. So the helicopter became the Army's most powerful weapon in Southeast Asia.
Also, people who looked at the lessons of Vietnam, looked at the air mobile ability of the Army, and said that the tank is a dinosaur. We won't ever use it on the battlefield again.
The tank, the critics said, was dead. It would turn out to be a premature epitaph. Most people connect Fort Knox with the nation's gold reserves. For those in the Army, however, Fort Knox is the home of the U.S. Army's Armored Center. Old tanks are arrayed like outdoor sculptures across its green spaces. One of these relics is a tank called the MBT-70. The prototype is all that remains of the ambitious co-venture with the Germans to build a tank superior to anything the Soviets could muster.
The main battle tank, which is the product of international cooperation, is a German-made automatic transmission that incorporates both converter and lock-up gear ranges.
The bureaucracy of two nations working together was in itself a formidable task.
The cost of the program kept rising, and finally Congress said, no, we don't want any more of this, stop it.
With a price tag of $1.2 million apiece for the new tank, Congress decided to cancel the program. Although it never went into production, the MBT-70 was an impressive piece of machinery.
Some of the characteristics of the MBT-70 that were clearly superior. It was able to move rapidly at speeds in excess of 35 miles an hour.
The MBT-70 was made so that it could rise up, shoot, and pop back down again without moving the tank at all, except for that built-in ability to elevate itself. But of course this all costs money, and that's one of the reasons that it went down the tubes.
Despite the failure to deploy the MBT-70, the Army did not give up its search for a new battle tank. In 1973, the Army instituted a competition between General Motors and Chrysler Corporation to develop a new battle tank for the least money.
Build us a tank that can be produced at $508,000. It had to be better overall than the preceding M60 tank.
The Army wanted to upgrade the M60 tank. It wanted to make that tank more lethal and more survivable. And this was given a very great push by the Middle Eastern War of 1973.
In October 1973, on Yom Kippur, the holiest of Jewish holy days, Israel came under surprise attack from Egypt and Syria. Scores of American-made Israeli tanks were knocked out by Egyptian infantry armed with Soviet-made, wire-guided missiles costing only $1,000 apiece.
It showed the vulnerability of the existing family of tanks because of the effective use of anti-tank weapons by the Egyptian forces and the Syrian forces. And those anti-tank weapons, of course, had been provided by the Soviet Union. Various members of Congress had been fighting tooth and nail against every military expenditure. And suddenly, after the Arab attack on Israel in 1973, they vied with one another to dump more money back into the military budget.
However, many congressmen were reluctant to pour more money into tanks, believing that their day as king of the battlefield was over. Critics pointed out that in their own war games, the Army had seen how wire-guided tow missiles, fired from helicopters more than 2 miles away, had managed to destroy an average of 18 tanks each before being detected.
When you invest millions and millions of dollars, even hundreds of millions of dollars in a tank that could be knocked out by a very inexpensive anti-tank weapon, it becomes a very questionable thing. In fact, it's obvious nonsense.
With even more effective laser-guided missiles in development, many predicted the tank would become obsolete.
I had expressed the opinion when I left running research and development for the Defense Department that in the long run, the anti-tank system would defeat the tank.
However, proponents of a new cutting-edge battle tank discovered something the critics had overlooked. The new anti-tank weapons used shaped charged warheads, which could easily penetrate armor with chemical explosives. But the British had invented a new kind of armor that was impervious to shaped charged weapons.
The Army learned really by accident that the British had developed a secret new method of making armor, and they were just amazed. The shells would bounce off this stuff.
The new armor was codenamed Burlington. It immediately breathed new life into a machine that had been on the critical list. In the mid-1970s, a new tank called the XM1 was being developed at the Army's tank factory near Detroit. Workers from General Motors labored at one end, those from Chrysler at the other. The competition between the two companies to win the contract was especially intense for Chrysler, which had built all of the preceding U.S. tanks. Dr. Philip Lett, who had been chief engineer for the M48 tank and project manager for the M60, headed up the Chrysler team.
In the early days of the program, our task force felt very keenly the need to win the tough competition we faced, and I reminded them at the outset that this was not a life and death matter, it was worse than that.
Both companies created prototypes using the lessons learned from the MBT-70 and the 1973 Arab-Israeli War. In addition, General Creighton Abrams, the Army's Chief of Staff, made survivability of the crew a top priority for the new tank.
A key person here is Creighton Abrams, who was one of Patton's young tank commanders in Europe, did some of the most spectacular tank forays against the Germans. It was he who made the decision and went for what many considered a too heavy tank because it incorporated enough armor to protect the crew.
I think in this country there is a tradition of placing high value on human life that's probably as high for any country in the world. Then it makes practical sense too. Beyond that, if your crew survives, they are able to fight another day.
The new special armor invented by the British and improved by the U.S. made this high level of survivability possible. Made up of a still classified, multi-layered protective plating over a hard steel shell, it was extremely heavy.
Special armor requires more volume. Several areas of the tank measured in feet and not in inches.
Engineers were forced to come up with a new 1,500 horsepower engine that could propel a tank weighing in at about 60 tons.
Probably the most contentious and difficult question was what kind of an engine should it have? The Army for many years and the Germans had good diesel engines. They had a lot of experience with diesel engines. They liked the diesel engine.
So General Motors went with a high-powered diesel engine. The Chrysler team came up with something completely different. Their tank had a turbine engine similar to the ones that power helicopters and jet planes.
We chose the turbine primarily because of its reliability. There was another advantage to the turbine, and that was its light weight. It was about 2,000 pounds lighter than the diesel that we were comparing it to at the time. And this meant that within our weight budget, we could put more of the weight into armor.
The turbine was so quiet and clean, the tank could almost sneak up on the enemy. It also accelerated quickly.
It can go from a standing start to quite fast in a very short time. It can go 60 miles an hour. It can jump over obstacles with this turbine engine, but also it will use up an awful lot of fuel.
There was great question, even within the Army, whether we should move to this new kind of powertrain as opposed to the tried and true diesel engine.
It was risky. We were not at all sure that this would succeed or be blessed by the Army, because no other tank in the world had a turbine engine.
The decision was especially important for Chrysler. The company was in financial trouble in the 1970s and needed to win the contract.
They went to a kind of a shootout where they demonstrated the tanks, and it seemed that General Motors had won. They were ready to pull out the champagne, but then there were some doubts. Is that really the tank we want? So in a very controversial decision, the Army went back and said, well, we're going to have a little bit more competition.
Dr. Lett and his Chrysler team made some changes that enabled them to underbid General Motors.
Chrysler went to their suppliers and said, let's get these costs down, and they came back, and at that time the decision was, well, Chrysler wins.
The new tank was a radical departure from those that had come before.
For the first time in a tank that I'm aware of, we separated from the crew all of the combustibles, the fuel behind armor in the front, the ammunition behind even thicker armor in the rear of the vehicle, so that when it was hit by enemy fire, as sometimes will happen in war, the ammunition would explode and blow-off panels would allow the fire that resulted to be exhausted away from the crew without injury to the crew.
A thermal imaging gunner's sight allowed the crew to accurately pick out targets at night. New digital computers replaced the analog machines, increasing the accuracy of ballistic fire and other functions. There were laser rangefinders, and in a revolutionary advance, the tank could fire almost as accurately while moving as it could standing still.
We had to come up with a stabilization system that would keep the line of sight of the gunner on the target as the vehicle was going cross-country, bouncing, pitching, rolling, etc. And it's much easier to stabilize with gyros the lightweight mechanism of crosshairs and sight than the gun itself. This is 12 feet of steel out there that bends and moves, and what we did with the inhibitor circuit was to allow the gun to fire only as it came into coincidence with the line of sight of the gunner.
While some argued for further technological improvements, Defense Secretary Caspar Weinberger decided to order the tank into production in 1981.
It had been in development so long because every 6 months or so somebody would decide something new that they wanted on it. And you had to come to finality and build what you had if you wanted to have a better tank available quickly.
In 1982, the superior new tank the Army had sought since the early 1960s was finally deployed. It was christened the M1 Abrams after General Creighton Abrams, who had died while serving as Chief of Staff in 1974. At NATO exercises, the new tank awed its remaining critics.
The M1 Abrams tank has a 105mm main gun. Dieser Panzer hat eine 105mm Kanone.
And this tank won all of the prizes, as so to speak, that the NATO contests for effective deployment and effective targeting accuracy, mobility, the degree to which it could be protected, and all the rest. It was a very, very good tank.
Most of the new M1 Abrams were shipped to Germany, where they were welcomed by U.S. Armored Forces.
The M1 tank was such an improvement over everything that had gone before that our soldiers, from the youngest to the battalion commanders just like me, fell in love with our new vehicle. One of the things that occurred to my driver as we were driving our new M1 through a maneuver course, he said, "Colonel, this is just like driving a jet plane on tracks." And he was right.
It could fire faster, it could fire on the move. The armor was described to us as being basically impenetrable by any known anti-tank weapon that the Soviet Union at the time could fire at us. So one of the big points for the soldiers was the survivability of the tank.
The M1 was pivotal in the strategy to hold the line against a Soviet invasion of Europe.
It was very important to have the M1 tank when we were talking about a major land war in Europe, or deterring a major land war in Europe, which you did not only by the strategic deterrent, but also by the forces in place there that made the Soviets at least think twice about whether they could sweep to the Channel within 30 days.
The threat of a wide-scale war in Europe faded, however, after the Berlin Wall fell in 1989 and the Soviet Union began to break up. The M1 had not seen action in Europe, but it would soon get another assignment. The Abrams battle tank had been designed to fight on the plains of Europe, but the first action it would see would be on the trackless deserts of Iraq during the Persian Gulf War of 1991.
All of those things that the Army had worked out were turned out to be very applicable to the situation when Iraq invaded Kuwait and we decided to respond.
Operation Desert Storm would be fought with an improved version of the Abrams, the M1A1. A more powerful 120mm cannon replaced the original 105mm gun. In addition, the M1A1 incorporated even more armor and new technology, including the ability to use the global positioning system from satellites.
The importance, too, in maneuvering on terrain that has no visual reference in most cases, very much like navigating at sea, was the use of the global positioning systems that were provided to armored force commanders.
Those systems would prove critical in the desert.
Armored units and armored cavalry units could move with certainty across this trackless waste in Saudi Arabia, Kuwait, and Iraq with the use of the global positioning system.
However, it took time to get the coalition forces ready for the war against Saddam Hussein.
In the Gulf War, it took us 3 months to flow the forces, to put them in place. And we were lucky that Saddam Hussein sat there and gave us the opportunity to flow the forces and did not attack at a time when we were most vulnerable, when we didn't have our heavy forces there.
Deployment of the Abrams tanks was delayed because they had to be shipped from bases in the U.S. and Germany on special cargo vessels or transported one at a time by C-5 cargo planes, the only aircraft big enough to hold one. Each M1A1 weighed 67 tons.
It's very heavy, and it requires its own transport vehicles, and it requires a service vehicle to be nearby. It also is not very good on gas mileage.
It's not all the tank's fault. The entire force is big and cumbersome and heavy.
Though the M1A1s had begun to be deployed in 1986, many tank crews got their first experience with them as they waited for the air war to soften up Iraqi forces. The Army decided that only the M1A1 with its more powerful cannon, not the M1, would be sent into combat in a land invasion.
No flag! No flag! Good cook is no damn flag!
The Army's out here, and there's no problem with us. We're pretty squared away. We have enough water. We have enough fuel. We can survive out here. We can live out here, and we can fight out here.
The armored units had to learn how to fight on a terrain vastly different from the one they trained on in Germany.
We were used to close-in corridors, restricted areas that would be a European fight. Now we're open spaces of as far as you could see. The maneuver exercises and training preparation allowed us to adjust rapidly.
When the land war began in February 1991, the M1A1s proved to be remarkably efficient, high-tech weapons.
The vehicles out in that desert environment, once you were adapted to it, it was the best ride in town. It was 70 tons going across open desert where no one had been in before. I mean, you didn't see a camel, you didn't see a goat, you didn't see a footprint.
First tank into Iraq!
The tanks could maneuver and make sweeping turns toward their targets, even in dust storms and the thick black smoke of burning Kuwaiti oil wells. Thermal sights also gave the American tank crews a big advantage over the Iraqis in their Soviet-made T-72 tanks.
And we could engage from ranges that the Iraqis couldn't even see us. 3 kilometers, 2 miles. essentially in the dark, in the bad weather, using the thermal sights. They couldn't even tell what direction the fire was coming from.
Colonel Jerry Wiedewich commanded a 1st Armored Division Brigade in Desert Storm. His brigade first engaged the Iraqis outside of a town the night of February 26th.
We had attacked all night with no real heavy resistance. I mean, they were so overmatched, and their tanks disappeared immediately with the first line of engagement by ours.
The brigade kept going, making such good time that on the morning of February 27th, they were well ahead of where they were scheduled to be.
When we came up out of the wadi, or the valley, that morning at about 11:30 and encountered a dug-in brigade, it was a bit of a surprise.
Ahead of them were elements of the Iraqi Republican Guard, dug in along Medina Ridge.
You know, they suddenly popped up on the horizon, but we were in excess of 4,000 meters, which was well beyond their range, so that when we began to engage them, they didn't know if it was from the air, from the ground, or where it was coming from until the thunder began to roll of the cannons firing on the horizon.
Gator 6, Red 1, destroyed 2 tanks.
The U.S. Armored Brigade was too far away to see the Iraqis with the naked eye, but their thermal sights saw the targets clearly, and ballistic missile computers directed the guns with lethal accuracy.
They would stay and die, or they would run and die, or they would run away from their vehicles, and some chose to do a little bit of each. And that fight lasted about 45 minutes, one brigade against another brigade, and at the end of the day, the score was 116-0 in our favor. All the vehicles were destroyed, which was our principal target.
The collapse of the Iraqi forces surprised the military and U.S. intelligence, who had not expected such an easy victory.
The expectations before the war in the desert were casualties as high as 10,000. Why did we think that? Well, they had T-72 tanks. They had been in a war with Iran for 8 years. What we didn't realize is the technological advantage we had over the T-72s that they were equipped with.
No.
Okay.
It's all right.
The Russian design and built tanks used by Iraq had one fundamental, I'll call it catastrophic flaw. And whenever the tank was punctured or pierced by an enemy projectile, the ammunition was ignited, it blew up, and when that happened, almost all of the turrets of those tanks were blown off, and of course the people were instantly killed and destroyed.
On the Iraqi side, more than 3,000 tanks were destroyed with heavy casualties. More than 1,800 M1A1s were deployed in the Gulf War. Only 18 were damaged.
Any Abrams which were destroyed on the battlefield in the Gulf, in the Desert Storm battles, were destroyed by other U.S. tanks. It was essentially friendly fire, fratricide.
We had tanks that were hit. No American tanker lost his life in Desert Storm as a result of enemy activity.
But the triumph of the M1A1 in Operation Desert Storm was short-lived. In fact, it wasn't too long before some predicted that the first wartime victory for the Abrams tank would also be its last. The end of the Gulf War coincided with the end of the Cold War. With the demise of the Soviet Union and the Warsaw Pact, funds for the U.S. military began to dry up.
President Bush laid out a plan for reducing the armed forces by about 40%. And in that environment, there were a lot of people who were asking, what is the role of the Army in a post-Cold War world?
The Army wanted to upgrade to the newest generation of Abrams tanks, the M1A2, but Congress was reluctant to fund the program.
We're proud to serve. We need your support for a budget which is drastically changed from the budgets of the past. We found ourselves in the position after the Gulf War of having so much downward pressure on the Army budget and convinced people that it was appropriate to have a new model tank where we just couldn't close the deal, so to speak.
Ironically, it was the Saudis who kept the tank program alive by replacing their old tanks with the M1A2.
They chose to purchase the M1A2 at a time when we did not have the resources and the political support or the support within the Department of Defense to do that. Was, I suppose, ironic in a sense, but certainly very beneficial and kept the production line open.
Ultimately, Congress agreed to upgrade the existing Abrams to M1A2 capabilities. Congressional reluctance to back the tank program, however, wasn't just about money. Many in Congress thought the tank was irrelevant.
And as I would talk to senators and congressmen about what the Army's needs were, especially in recapitalizing our equipment, part of what I would hear is, well, if what you want this new money for is to invest in 70-ton tanks and Cold War legacy platforms, I'm not sure I want you to have the money. Because I don't think that that is the weapon system of the future.
Much of the motivation for improving tanks has weakened. In the first place, there is no threat out there at all comparable to that which was represented by the Warsaw Pact.
In addition, critics pointed to how long it had taken to move in the heavy forces in the Gulf War. They wanted a more rapidly deployable force to respond to international crises.
What's that? No, put that here.
Increasingly, the military was being called on to be peacekeepers and policemen, not warriors.
The threats are different now. You've got to be able to get to the hotspots faster, and your 70-ton tanks will never get there. They can't operate in many parts of the world because they're too heavy for the bridges, they're too heavy for the roads, they're too wide for the narrow streets. And as you see the world becoming much more urbanized, fighting in cities becomes a real challenge.
The shortcomings of the tank became evident during the U.S. involvement in the Balkans, particularly in Kosovo in 1999.
The tank itself was designed for employment where there is a supportable infrastructure. In the case of the Balkan area, much of that infrastructure was archaic and would not support the full mix of vehicles.
That was a 78-day war. It was over before you could have gotten ground troops to the fight. And that was one of the big lessons for the Army. Namely that if you can't get to the fight, you're not relevant. If the Army's future just lay in 70-ton tanks, we were not going to be relevant to the future fights. We were not going to get the funding and support that we needed for Congress. We were not going to play the role that we needed to play to properly defend the nation.
Recognizing the new realities, Secretary of the Army Louis Caldera and Army Chief of Staff General Eric Shinseki developed a new plan for the Army, creating an interim medium-strength force that could be deployed to hotspots quickly.
The Chief of Staff of the Army's current goal is to be able to move a brigade-like capability in 96 hours anywhere in the world.
The plan calls for 7 brigades to be mounted on light armored vehicles and future combat vehicles instead of tanks. The M1A2s would become part of 3 legacy brigades to be called on if needed.
The world has changed, but there are still a lot of folks that could be enemies that have large numbers of tanks that we could possibly have to fight in the near future. But the challenges that we face are much different than fighting a tank battle. The challenge of Bosnia, of Kosovo, the challenge now of terrorism in Afghanistan requires a different focus for our fighting force.
Go, 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 go!
Today there are 2 Army brigades at Fort Lewis, Washington, who are training on light armored vehicles borrowed from other countries. The U.S. Army's own light vehicles, which move on wheels, not tracks, were due to roll out in 2002.
In signaling that we were really looking for something revolutionary, we made the statement that this might be a wheeled vehicle, that it wouldn't necessarily have to be a tracked vehicle, that we wanted people to think out of the box.
If you've ever been a tanker and you threw a track, you only throw them one time. because it is a lot of hard work to get it back put on. So I think operationally, the wheels do have an advantage. Wheels can travel faster on high-speed roads, good roads. They're equally good in most off-road terrain.
The Army is also exploring ways to make future combat vehicles that would be as lethal and survivable as the 70-ton Abrams, but a lot lighter.
That takes a leap in technology, and all sorts of technologies are being looked at. Stealth technology, having a false image projected so that when they do shoot at you, it misses your vehicle and hits your image.
It may fly, who knows? I mean, it may levitate off the ground. I don't know what the answer is, and I don't think anybody does.
In the meantime, at Fort Knox, soldiers of the Armored Cavalry train on simulators for the M1A2 SEP tank, the latest version of the M1 and the most sophisticated battle tank in the world.
They have sights that can see twice as far as we did in the desert, in Desert Storm. They have a higher level of protection. The lethality that comes within their weapon systems are beyond comparison anywhere in the world.
A separate thermal viewer for the commander allows him to pick out a second target while the gunner is engaged on the first. A screen shows where the enemy forces and the friendly forces are at all times. Shooting at targets has been made almost foolproof.
You have to make a very big mistake or do it on purpose to miss the target.
And when artillery is able to shoot the first round out of its tube within 1 meter of the enemy target and kill it, that's close enough.
Today, these high-tech battle machines are the pride of America's armored forces. But within the next 20 years, they will probably be retired to grace the grounds of Fort Knox like their predecessors.
But eventually, the Abrams may be the last tank that was produced, and the tank will have played a glorious role in defending and protecting our nation and our freedoms. But like all things, there will be a day when it passes.
Until that day, the Abrams tanks will be the best in the world.